Hello students, how are you all? I hope all of you are very fine and you are doing preparation for your midterm examination. So in this video lesson also I am going to give a short revision of chapter number 5, language of chemistry. It's a very important chapter. Okay. So in this language of chemistry, first is what is chemical reaction. You know, when any substance goes for a chemical change, we represent it in with the help of some symbols and formulas, that is called chemical equation. So whenever a chemical change happens, it's also called as known as chemical reaction. Any chemical reaction has its two parts, that is called reactant and the product. The substance that undergoes for a reaction, they are called reactants, and after reaction some new substance, one or more than one new substance may form, they are called as product. Okay. So whenever anything reacts with each other chemically, actually what happens, they react with each other, elements reacts with another element, whether it is with non-metal or non-metal, metal non-metal, they attain to become stable, they react. How they become stable? To gain the nearest electronic configuration of noble gases. Okay. So it is then it becomes stable. Now the condition required for a chemical reaction, first of all, is the close contact. So unless and until you bring the substance close to each other, they will not react. Okay. So to have a reaction, first of all, we have to bring the substances in close contact. If they come in close contact, they may react or they may not react also. If they react, so it's the first condition, that contact is required. For example, if you react sodium with water very vigorously, because sodium reacts with water, reacts with hydrogen, it burns. Okay. Next condition, if you see when you bring the substances close contact, then also they are not reacting with each other. To make them react with each other, sometimes what we do the dissolution, that is called soluble form. Means if any one of the substance that present in the reactant part, if they are not reacting with each other, sometimes we put some liquid substances to it. Suppose you can add sometime water also, they will react with each other. Okay, for example, if sodium chloride with lead nitrate is a solid are placed contact with each other, they will no reaction. But if you mix water with it, what will happen? They react with lead chloride and sodium nitrate. So this solution is called aqueous solution. Here you will see the reaction takes place. Though after adding some solvent into it, making the soluble solution, sometimes they not react. For that, what we have to do? We go for heating process. So heat is another condition that is required for reaction. Sometimes if you heat the substances, they undergoes for a reaction, because suppose sulfur and iron, if you mix together, you can easily separate iron from the mixture by using a magnet. But if you heat it, it will become iron sulfide. From that you cannot separate them. So it is a chemical reaction on heating. Sometimes light is also required. For best example that light is required is the photosynthesis. Other than is the formation of hydrogen chloride. So when you bring hydrogen and chlorine together in the presence of sunlight, they react to form hydrogen chloride gas. After this gas, when you mix it with water, it will become hydrochloric acid. So similarly, carbon dioxide is also used for fusing with react water to form carbonic acid. Okay. So here pressure is required for this reaction. So very important, if you want to make the aerated drinks more tasty and fizzy, that means you have to decrease the temperature. So in low temperature, carbon dioxide is more vigorously mixes with water to form carbonic acid, which will give more fizziness. Same if you want to make a form ammonia gas, nitrogen hydrogen is also react under 200 atmospheric pressure, so here pressure is required. So many other examples also you will study in your chemistry in further classes. Okay. Next, sometime electricity is required. So for the decomposition reaction, sometime electricity requires. So if you want to separate hydrogen and oxygen from water, we have to pass electricity to it. So it will decompose to form hydrogen and oxygen. Similarly, if you want to separate nitrogen, sodium and chlorine from sodium chloride, again from in sodium chloride solution, if you pass electricity, you can separate sodium and chlorine. So here this process is called electrolysis process. So passing electricity to decompose a compound, this process is called electrolysis. Sometimes it is also this process used to purify or refine the metals. Sometimes some reactions are very slow or sometimes they are very fast. To control the rate of reaction, sometimes we use some element or compound that will not take part in a chemical reaction, but they will control the rate of reaction. Either they will speed up the reaction if it is very slow, or they can slow down the reaction if it is very fast. And the substance that do this, they are called catalysts. Okay, so for the formation of ammonia gas, we use iron as a catalyst. Okay, it is a positive catalyst here. Next is the type of chemical reaction. First is the combination reaction. When two or more elements are combined together to form a single compound, it is called combination reaction. Suppose hydrogen plus water, oxygen, is water, carbon plus oxygen, carbon dioxide, and incomplete combustion, it is carbon monoxide. So the nitrogen and hydrogen, ammonia. So all these are the examples of combination reaction. Burning of magnesium ribbon in the presence of oxygen, it is also a combination reaction. Magnesium oxide you will get. Now the decomposition reaction. Just now I told you for heat is required, sometimes electricity is required to break the compound to its individual elements. Suppose water, electrolysis is required, electrolysis process. They decomposes to form hydrogen, oxygen, sodium chloride. These are the common. Potassium chloride decomposes on heating to form potassium chloride and oxygen. So potassium chloride on heating, chlorate on heating, it gives potassium chloride and oxygen. Okay, so many examples we will study in further classes about decomposition reaction. Next is the characteristics of a chemical reaction. How can you say a reaction has taken place? By seeing. First is the change in color. Suppose iron, when exposed in air for a long time, a reddish brown layer forms on its surface. It is called rust. So iron reacts with moist air, that is moisture and oxygen, to form hydrated ferric oxide. It is a rust. So it is a change in color shows. Change in state of matter also takes place here. So potassium chromate, which is a liquid, and a solution of barium nitrate is a liquid to form barium chromate. Okay, so here the reaction of potassium chromate and barium nitrate, with both are liquid, but when they react, barium chromate is formed, which is a solid state. Similarly, hydrogen is gaseous state, oxygen is also gaseous state, but when they react to form water, it is a liquid state. Sometimes gases are also evolved, that is called effervescence, the evolution of gases. For example, zinc react with hydrochloric acid or sulfuric acid to form zinc chloride or zinc sulfate with evolution of hydrogen gas. Okay, so this here also we can see the evolution of gases required. So next is the evolution of smell. Sometimes pungent smell or other type of smells also come out after a reaction. For example, given in a book is sulfur react with hydrogen to form a strong foul smell of hydrogen sulfide. It's a pungent smell. Okay, very bad smell it gives. Release or absorption of heat is required for a reaction. Okay, so if heat energy is required in a reaction, that means it is called endothermic reaction, whereas after reaction sometimes heat energy is released, it is called exothermic reaction. For example, sodium hydroxide with HCl, heat is evolved here. It will form sodium chloride and with the evolution of heat energy. So it is exothermic reaction. Another examples are also there. Next is the where heat energy is required for a reaction. Suppose the formation of ammonia gas, nitrogen and hydrogen is heated at the temperature of 450 to 500 degrees Celsius. So here heat energy is required for a reaction, so it is called endothermic reaction. Also, dissolving ammonium chloride in water, sometimes heat energy is released. Next is the precipitation reaction. Precipitation means insoluble solid substances are formed after a reaction. They are called precipitate. Suppose for white precipitate of barium sulfate is formed when the reaction of barium chloride with added to sulfuric acid. Okay, so these are the characteristics of a chemical reaction. By seeing these things, we can say that a chemical change has been taken place. Now, whenever you have these chemical changes, we can represent them in a symbolic form with some symbols and formulas. That is called chemical equation. So, representation of chemical reaction in a symbolic form by using symbols and chemical formulas are called in the reactant and the product part both is a chemical equation. So, if chemical equation has three parts, first is the word equation, then unbalanced chemical equation that with symbols and formula, that is called skeletal equation, and after that we need to balance them according to the law of conservation of mass. We need to balance them, but in this class we don't have to do the balancing, just you have to know that we need to balance the chemical equation. Few examples are also given in your book of these things. So how the burning of carbon is a combination reaction with oxygen. It's a carbon dioxide. So carbon plus oxygen gives carbon dioxide, means C plus O2 gives CO2. Now you have to balance it if it is not balanced. So many examples are given. Combination of carbon dioxide with water gives a carbonic acid, that is CO2 plus H2O gives H2CO3. So this is symbolic representation, which is called chemical equation or skeletal equation. If it is balanced, then it will be called as balanced chemical equation. So these things that we have to remember in this chapter. After that, go through the whole chapter, and in chapter number 4 the charts are very important, because from this if you don't learn those charts, you will be not able to frame a chemical formula. If you are not able to frame a chemical formula, you will be not able to write a proper chemical equation, or from a word equation to a skeletal equation. Okay, so very important to learn the symbols of elements, their valencies, then molecular formula of elements, then radicals or polyatomic ions, formula and valency. You have to remember these things. Then only you can make the chemical formula, okay, and chemical equation. So these things are there in this chapter. So best of luck for your upcoming midterm. I hope all of you will do very good result in this midterm. Thank you very much for watching this video. See you again in the next video lesson and online class. Thank you very much.